Today what we'd like to do is a basic introduction to statistics. What is statistics? What are we looking at? And some of those basic ideas. So, what is the goal of statistics? It's to learn about a large group by examining data from some of its members. So think about when you're doing a college application or a job application and you check off the boxes. Even at the doctor's office, you have to check off the boxes as far as male, female, age range, income range, marital status, things of that nature. All of this data is collected and organized and summarized, and then they analyze it. That's the biggest thing about this. So when we're talking about statistics, statistics is literally that science of collecting the data, organizing the data, summarizing the data, and analyzing information because we want to draw conclusions or answer questions about it. In addition, statistics is about providing a measure of confidence in any conclusions. In later videos, we'll talk about confidence intervals and how confident are we. Well, when we are drawing and collecting data, or even designing an experiment to collect data, we have to look at all the aspects and would it be accurate if we projected that information onto the entire population? Did we do things without bias? Did we get a large enough sample? Those types of things. And so we have to be able to look at those items when we're talking about it. So, data is a fact or proposition used to draw a conclusion or make a decision. Data describes characteristics of an individual, which in turn used to draw a conclusion or make a decision. These characteristics, again, can be gender, or they can be marital status. They can be height, weight. How many children do you have? How many dogs do you have? What city do you live in? Are you Democrat, Republican? All of this is just considered data. Then what we want to do is we want to look at how this data is gathered. What is the information that we're looking at? How can we determine, is this a correct statement or not? So the first thing to note is population. Population is the entire group of individuals you want to be studied. So, for example, a population could be all adults in the U.S. A population could be all adults in the city. Or a population could be all students in a classroom. It could also be all grades for a student, or it could be all race times for a runner. If you're looking at this and you want to look at all of something, that's going to be your population, okay? It's everybody. Then an individual is a person or object that is a member of this population that's being studied. So for example, think about your grades. Say that we're looking at all of your college grades, okay? A grade in your science course would be considered an individual because we're looking at all of your grades. And therefore, that would be the object that we're looking at, okay? Now then, a sample is just that. It's a subset of the population being studied. The sample must be representative of the population from which the data is drawn. What I'm talking about there is you have to be careful about how you draw your sample, how you take a sample. Does it represent the population you're looking at? Let's just take people, race, male, female, that type of thing, okay? If you want to look at all people in a city, well, your sample must be proportional male versus female, or proportional as far as ethnicity. If you don't do proportional values, then you get that biasness, and it's not going to be an accurate interpretation, okay? Most of what we do is actually called descriptive statistics. Descriptive, and I'm not spelling that correctly, let me back up. Okay, so descriptive statistics. It consists of organizing and summarizing the data through numerical summaries, tables, graphs, that type of thing. It's the collection. It's the getting it all together. What does it describe? It's not making any type of projections or anything like that. Descriptive statistics is what you see most of the time. It's your tables, your charts, the graphs that are created. And that's what we want to look at. So a statistic is a numerical summary of a sample. So, example, the average age of all statistics students at the Central Park campus. This is a Collin College campus. The reason why that would be a statistic is because it's all statistics students there. It's not all students at the Central Park campus. Also, an example of a statistic is the average salary of the Dallas Mavericks. It's not the average salary of every NBA player. It's strictly one team. And we could even break it down if we were looking at all Dallas Mavericks, just to get a number there, then we could say that our sample would be the starting five or something of that nature, okay? Inferential statistics is where we have a lot more calculation and things of that nature. So inferential statistics uses methods that take a result from a sample and you extend it to the population. In other words, you project it onto the population and you measure the reliability of the results. It says we use statistics to estimate the parameter. So that's meaning we use the values from the sample to estimate or project what the population is. So take some of the surveys that you've done, okay? Maybe it was a mail-in survey or something along those lines. And we want to get an idea of the average age of the people in an area. Well, we don't have the information for everyone. We have the information for a sample. Therefore, it's going to be one of those things that you need to look at and identify with, okay, if this sample has this approximate age, then overall that is going to be the average age that we're looking at. Or if this class has this type of average, on average, all classes will be around that value as well. That's what inferential statistics is looking at. This values that come from populations are called parameters. This is if we have the entire population to look at. I want to bring in a little bit of politics right now so that we can really understand the difference between descriptive statistics and inferential statistics, okay? So think about the population as being all registered voters. So we're looking at all registered voters. Well, you've seen some of those studies and everything on television, especially during election year, saying that one candidate is ahead of the other by so much percentage. Okay? That's before the polls even open. Well, here's the thing. Have they asked you? Are you a registered voter? Did they ask if you agreed with that person? Or, for instance, also in the political standpoint, the president's approval rating. Well, I'm a registered voter, but they didn't ask me. What they're doing is they are taking this sample and getting a statistic to see how many people approve of the president, that type of thing, and then they are inferring it back onto the population. We don't actually have the parameter, but we're estimating that parameter. Okay? Those are some things that we kind of look at. So let's look at example 1. Suppose the percentage of all students on your campus who have a job is 84.9%. This 84.9%, does it represent a parameter or a statistic? Is it about the population or is it about the sample? Well, our key word here is that all students. We are looking at all. We have the value of all. Therefore, this represents a parameter because it's of the population. Now, suppose a sample of 250 students is obtained. From this sample, we find that 86.3% have a job. It says from this sample, we took a sample of 250 students. We didn't have all the students. Therefore, this is a statistic because it's based on a sample. So this right here has just been a small introduction into statistics, getting a few of our definitions out of the way. So I'd advise you to go ahead and try some of these. Next video, we will get into the sampling techniques that we look at.